Okay. Before we start the opening problem, right? You look at the opening problem. Okay, this is the probability distribution table. This table is called probability distribution table. Okay, why I call it probability distribution table? Because instead of stating frequency, I state probability. So what do you mean by probability? What do you mean by probability? Then it means the possibility for something to happen in the population. So when we talk about probability distribution table, remember, we are talking about population. Because you include everything in the population when you state in a probability form. That means you are talking about, when you have the probability, that means we are talking about part from the whole. The whole thing is the population. Are you clear? Part from the whole. Okay, so that is called probability. So probability, we always state in decimal. You also can state in possible fraction. All right. So now probability, that means the possibility for something to happen. So the moment you see probability distribution table, you are talking about population. Or if you see it as a percentage also can. If I have the probability, look, for this, so every time when I draw a table, when in maths, correct, we don't put the word, we always represent with a variable. So now instead of tell you the price value, so what is the variable in this opening problem? Can you tell me? Okay, so what is the one? The probability of winning this prize. So our X, we define as what? Winning prize. Okay, winning prize. Prices. So I put X here. So I put in dollar. So that is the usual one we do. So he said there is a 50% chance to win a prize. Which prize, I don't know. So that means when I put 0, what does that mean? If X is 0, what does that mean? Can you interpret this? Doesn't win a prize. Right? So that's why you have to put 0.5. Because they say 50% chance of winning a prize. So that means you doesn't win a prize, the chance is 50% also. So this is the probability. Usually we write it like that. Okay? So this is the way we write probability. Okay, what is the probability of winning a prize of $2? 0.35. $5. $10. $20. Okay, now, and this is given 0.1. So based on the information given, okay, and this one, so you look, it shows that the sum of all the, sometimes we write this as PI, okay, sometimes, okay, can you tell me what is the sum of PI? Probability for the whole situation to happen. What is the value that you get? Is equal to 1 because it's one whole. So that's why it's talking about population. Why must this answer be that? So always remember, from now onward in this chapter, whenever you talk about probability distribution table, this is the first thing that you have to bear in mind. Sum of all the probability in the probability distribution table must be equal to 1. If it doesn't equal to 1, that means something wrong with your calculation. You get me? Okay, what is, okay, then we answer part B. What is the most likely outcome for playing the game? Which one has the highest probability? So that means in this question, part B, they are asking for mode. Am I right? So what is the outcome? Not winning a prize, right? Am I right? Because the probability is the highest. So part A, done. Part B. Are you okay so far? So yeah. So X equal to 1, Okay, so part B is, what is the most likely outcome for playing the game? So the most likely outcome is outcome. That means bear in mind highest probability. Okay, is Jane doesn't win any prizes. That is X equal to 0. Right? So what is the average? Okay, now everyone key into the calculator. What is the average? Can I have the answer? 0.2? Cannot be. 0.22 dollar only. Sure. Is it correct? Do you all know how to do or not? Okay, 0.2, okay. So 0.20. So what does that mean? So what is the meaning of this? So I will write this as for each game. Play by, for each game. Okay, I just put it, no need to play by. For each game, the player expect to win $0.2. Or I can say for each game, the store owner has to give the player what is it? Can you please show how to get 0.2? Okay, those who can know how to get 0.2, can you please show? Can you explain, someone?
This is this calculator, right?
Yeah, you use calculator, yes.
I think the answer is 1.8.
The answer is 1.8. Can someone check? Or is there anything wrong with my table here? 3.5, 0.1, 0.04, 0.01, I'm right. Is it 1.8 or 0.2? Confirm, please.
0.2 is just adding the probabilities together and divide by 5.
Aha. So is 0.2 or 0.8? Or 1.8? Hello? Do you know how to get this answer? You go to stack. Aha. You go to stack. Go edit. Then this one you key in L1. This one you key in L2. Then after that you do second mode. Then after that you go to stack again. Then you do calculate. Then you select number 1. So what is the answer? Can you please tell me? Hello? 1.8. Okay. So that's why just now I said cannot be 0.2. No one will want to play the game. Average is 1. Okay, 1.8. So for each game, the player expected to win $1.8. For each game, the store owner has to give the player 1.8. Expected only, not always true. Yeah, so now, this is the part whereby it gives us the decision. What is a fair price for playing this game? Now, what is the fair price? When you say fair means no lose, no gain. So you give me a suggestion of a fair price. Hello? Can someone give me a suggestion for the fair price? Hello? Huh? You use median? I expect to gain. So if how much should I give the owner? If I want to play this game, how much must I pay? If I pay 2, I only expect to get back 1.8. So I lose 20 cents. Player in disadvantage. if the owner only charge 150, in the long run, every player he is expected to pay 1.8. So in the long run, he's running at a loss. So you tell me, fair price for playing this game is what? Someone have given me the answer through the chat. Okay, Ashley, give me a suggestion. Hey, this one will be your S81. The first question will be like that. S85. Ashley, give suggestion. No gain, no loss. That is called fair.
No gain.
No gain, no loss. So that is called fair. So the owner, when the player come and play, the owner have expect to give him the price of 1.8. That is the meaning of the mean. So give me a suggestion, Ashley. Faster lah, give a number lah. There are so many numbers here.
1.8.
Yeah, 1.8. Isn't it? So the price for playing this game is 1.8. So it's fair. I pay you 1.8. I expect to get from you 1.8. So anyone gain, anyone lost? No. So that is the fair game. So do you know now how? Whereby Ms. Do said you have to know that average is expected. Okay, I will put this. Expected to give the player 1.8 as the price. You get me? So that is called average. That is, or another word, we call it the mean. So that is how we use to judge how much we should charge people. So do you think the storekeeper will charge at 1.8 to play the game? Definitely no. They will charge at 2. At least they want to earn one. Am I right? So any games that you play in a fun fair or whatsoever, is it a fair game or not? Definitely not a fair game. They will charge you more for playing that. Get me? Hello? So 2 important points through the discussion of this and how to use your GC. Okay, the random and discrete variable, I'm not going to explain because I explained it. So this chapter, we are going to talk about a discrete variable, that means countable. Continuous variable means measurable. Okay, let's go to exercise 7A. I want to teach you from exercise 7A. Just on my 1 hour break, I sit down and think about it. Then I say I better discuss through. Then from there, I tap onto what I want to teach. Okay, 7A. Classify each of the following variable as continuous or discrete. A, the quantity of fat in a sausage. Continuous. This is talking about quantity, means the weight. Yeah. So, okay, Adriana, continuous or discrete?
Discrete.
Okay, why you say discrete? If you want to measure the quantity of fat, you use the weighing machine, correct?
Yes.
So, is it a discrete or continuous? Okay. Bear in mind this thing. Discrete means what? Discrete means they take whole number. Just memorize like that cannot. Okay, if I talk about continuous, just to make you, they can take decimal. You can take decimal number. Can or not? If I put it like that, instead of countable and measurable. But please, in your presentation, in the presentation of your folio, the writing, you please don't write this. You write this, I sure will deduct mark. Because this is not mathematically sound. You have to say discrete are those countable and it take whole number. Continuous are those measurable in it take decimal number. Then it's fine. You get me? Okay. Now, so A is continuous. Okay, how about B? Armahan, the mark out of 50?
Out of 50 for a geography test would be discrete.
Discrete. So you can get 5 marks, 10 marks, 15 marks, whole number. Okay, Ashley, C, weight of year 12 student.
Continuous.
Okay, Ken, volume of water in a cup of coffee. Brandon.
Continuous.
Okay, E, Jian, the number of throat in a leg.
Discrete.
The moment you see number, you know already. Okay, number of hair on a cat. Okay, this is definitely discrete, but please bear in mind, don't give that as an example. I told you already. Okay, Cindy, the length of a horse mane, yeah.
Continuous.
The length. You use ruler and measure.
Yeah, so it is continuous because it is measurable.
Yeah, it have to be continuous. Okay, EJ, the height of a skyscraper.
Continuous.
Continuous. Okay, so you know already, Okay, number 2, you can go and do it by yourself. Okay, number 3, I want to talk about number 3. Yeah, I want to talk about number 3, Okay, suppose a spinner alongside us spun and X is the sum of the number. Okay, so X is my variable. Sum of the number. I'm going to build probability distribution table for this one. Okay, now explain why X is discrete random variable. Because the number in both spinners are whole number, correct? So their sum will be whole number as well. Okay, someone cannot hear me? Yeah, you can leave. Yes. Okay, you just, whatever your message me, you just leave. Okay. Okay. Hannah? So that is the explanation. State the possible value for X. Okay, now how are we going to state the possible value for X? So we have a few different ways. Still remember you learned in year 11, how do you find the possible way when you toss 2 coins? Still remember that? Hello, still remember that? Okay, we have spinner A. The number is 1, 2, 3, 4. Okay, spinner B. And the area all are the same, correct? Okay, so now when we talk about, we get the number from the spinner. If I list out the possible outcome, I'm going to patiently list out for you. List out the possible outcome. It will be the first one. Okay, I put in like a coordinate form. The first one is from spinner A and the spinner B. Right? Okay, so I'm talking about A and B. Okay, so I have this possible value for X. 1 plus 1, that is 2. This spinner A, this spinner B. So what is the probability of getting 2? Can you tell me? When you have the word and, you time by the probability of getting 1 from spinner A times by the probability of getting 1 from spinner B. Remember, and they are independent. So when you have and, you multiply the probability. See? So this one, that means probability of X equal to 2. This is one possible outcome only, is equal to, okay, I will say one possible outcome only. I will not put X equal to 2. Okay, so it will be equal to, okay, can you tell me what is the probability of getting a 1 from spinner A? Ethan?
0.25.
Okay, how you know it's 0.25, Ethan? Explain.
Yeah, you take 1, which is the maximum, and then you divide by the 4.
Yeah, because spinner A is divided into 4 equal parts. And 1 take 1 part. So usually, instead of put 0.25, we will prefer to put as fraction. How about spinner B? What is the probability of getting a 1 from spinner B, Ethan?
1/6.
Yeah, 1/6. So you multiply, the answer is 1/24. Actually, for each number in spinner A, the probability of getting it is 1/4, right? Because they are divided into equal parts. You get me? Okay, then I can have many possible outcomes. I can have 1 and 2, 1 and 3, and many, many more, correct? So you think presenting like that is a good way of doing it? By listing out? For this case, do you know there are how many possible outcomes? How many possible outcomes? Who can tell me? I have to write how many times? Here got A got 4 possible outcomes. I'm teaching you the outcomes. B, we have 6 possible outcomes. Okay, for A and B to happen, we have total 4 times 6, that is 24 outcomes. So you list out the 24. Do you think it's easy to list out in that way? So we can also, so listing out like that is not a good way for this case. I'm saying this is one of the way, but it's not a good way. So I have to list out all the 24. So if I have many possible outcomes, so what I can do is I can use this method. This is from A. I can have 1, 2, 3, 4. Plus, this is from B. So I have a grid of 4 by 6. Six. Okay, 1 plus 1, 2. Okay, can you please fill up this table by yourself? Then from here, we can build the probability distribution for X. This will be a much easier way. Right? Okay, so what are the possible value for X? Whatever show inside this table are the possible value for X because of the plus. So X can be 2. So altogether, I have 24 outcomes. How many 2 are there? 1. So 1 out of 24. How many 3s are there? Can you fill up the table? And afterward, I let you check with mine. Okay, I don't have space, bear with me. Didn't plan properly. Okay, so do you get that? So how many 3 are there? 2. 2 out of 24. 4, there are 3. 5, 1, 2, 3, 4. 6 also got 4. Seven also got 4. 8 got 3. 9 got 2. 10 got 1. 1, 2, 3, 4, 5, 6, 10, 20, 24. So now you understand? You build probability distribution table. There are many ways of doing it. If you want to list down, there are 24 outcomes here. How I know? Because A got 4 outcomes and B got 6 outcomes. So for A and B to happen together, I have 24 outcomes, 4 times 6. You get me? Hello? But what is X? X is not the number in A, not the number in B, it's the sum. That's why I put here sum. I can also change to product. Products of the number shown. Then that will be a different story. Hello, do you get me? Can or not? Okay. Are you okay?
Yes.
So what is important here is not to determine whether the variable is, you must know how to build the probability distribution table. So that's why I prefer to go through that with you. Okay. If you understand that, then when we go to the 7B, then you have no problem. Okay, let's go to questions 4. Okay. So state the possible value for X. How many games must they play? How many games must they play? So X is the number of games. So if I build the table, after I'm going to add on something. And here I'm going to put the probability. Okay, X is a number of games. So how many games? Minimum, how many games must they play? So that means if that W represent winner, okay, and is not win, okay? So when I talk about first game, win. Second game, win. Third game, win. Fourth game, win. I'm talking about team A. Okay? So how many games you need to play? Hello? These are one possible way, correct? So you have to play 4 games. Okay. So or team A, first game lose, second game win, third game win, fourth game also win. They need to play on or not? Hello? Need to play on or not?
Oh, they need to.
Just saying. It's only 1, 2, 3. So you need first team to win 4 games. So you have to play another game. Maybe you win. So minimum must play 5 games. That means 4 out of 5 you win. This is called 4 out of 5. The situation, this 4 out of 5 can also be like that. Win, no win, 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 win. So 4 out of 5, you got how many ways? How many ways? You still remember your combination? 5, C, 4. That is called 4 out of 5. Can you please tell me what from your calculator? Do you know the meaning of 4 out of 5 or not? That means in a group of 5, you choose 4. How many different groups can you get? This is called number of different ways of winning, number of different way of being a champion. I purposely write down all these because this is a very helpful thing for our being a champion by playing 5 games. So you got how many different ways? 5C4? Can anyone tell me what is the answer?
5.
5. So there are 5 different ways. That means you lose the first game, you win the following 4 games. Or you win the first game, you lose the second game, and you won the other 3 games. Do you understand what I mean? Or it can be like that. So they are all together 5 different ways. You can go and list it out. Okay, so 5 games. Okay, so this is another one. So we can also have the situation whereby if my first 2 games I lost the game, then after that, how many games must I play? Continue to play to win. 1, 2, 3, 4. So altogether, how many games? Minimum 6 games I must play. Right? So that means over here, we are talking about 6 games, you won 4 games. How many different ways? So this is the number of ways. How many different ways? Hello? 6.
15.
Yes? 15. 15 6 times 5 over 1 times 2. Yeah, 15. You're right. Okay? So the last one. The first 2 games I lose. Then I continue to play 4 games. Then I win. So this one is 7 games. So it's 7C4. So the maximum number of games you need to play is 7. If you go to 8, then it will be draw already. Definitely cannot be 9. Are you okay? Because if you say play 9 games, you lose 5 games, the other party will, the moment the other party win, then it's win already. Are you okay? So how to get the probability? This one we will learn in the other part. You want me to show you how to build a probability distribution table for this one? Okay, who can tell me what sort of distribution is this? You learn it in year 11. You tell me what sort of distribution is this? Hello? Okay, can someone tell me what is 7C4? $35. Okay, now listen. If I tell you the probability for team A to win a game is 0.7. Okay, so what is the probability of winning 4 games at one go? First one wins, and second one wins, and third one wins. So it will be 0.7 to the power of 4. Am I right? You have any idea of this? Hello? Can you respond to me? Because it's the n, so you have to multiply the probability, right? So how about this one? Probability of lose a game but win the other four for one of them. It will be 0.3 times 0.7 to the power of 3, to the power of 4. But there are how many? 5 possible. So you have to times with 5. Then this probability you put into here. Okay, so far you don't have to worry. I'm just telling you how is the situation like. Can or not? That is question 4. Same go with question 5 and so on. Okay, So look, you should be able to do exercise 7B. If you look at exercise 7B, if you look at number 1, what do you need to do? They say whether it's the valid probability distribution table. Probability, listen, there are 2 criteria. This is the condition. This is the first criteria. This is the second criteria. Sum of the probability in a probability distribution table must be equal to 1. Okay? So number 1, is it correct? You go and add up. But I know that part 4. I shouldn't put 1, 2, 3. These are the 2 criteria. Okay? Okay. Part 4. Can you tell me part 4, is it a valid probability distribution table? Part 4, is it a valid probability distribution table? Shah Ahmad? Is this a valid? Are you sure? You look at the probability of getting a 5. What is the probability? Can this happen? No, probability can never be negative. So this is invalid. So this is something that you have to remember. Okay, like number 2. Is this a valid probability distribution table? What do you get? You get 1.1, more than 1, not valid. Are you okay? So, can you please practice 7B? Either use your calculator or, so I will, expected value also you can do it. So please, tomorrow lesson, I will discuss further 7B, some of the questions, 7C, so, and 7C. Okay, so please, try to do some of the question. Okay, probability, I need you to practice by yourself. Whatever in the textbook, please finish it first. Okay? Class, you read, you try to understand it by yourself first. Okay? Hello? Thank you.
Thank you, Miss.
Thank you, sir.
Thank you.
Yeah.
Thank you, Miss.
Thank you, Miss.
Mm,
All right, thank you, Miss.
yeah,
Thank you, Miss.
thank you.